Quadratics Review Problem 2. They give you a equation for the quadratic, and they give you a graph. So they're going to ask you about certain points on the parabola based on this. So probably the first thing you want to do is, since they give you an equation, why don't we graph it on the calculator? So we'll put 3 plus 4x minus x squared. And you can see they're trying to be a little bit tricky because they gave you the x squared term at the end instead of at the beginning. They didn't say negative x squared plus 4x plus 3. They said it the opposite way. There we are. So that kind of looks like the drawing they gave us. So the first thing they want to know is find the coordinates of B, and B is the vertex. Let's see. Well, there's a couple ways we can find the vertex, and one of them is we could use the axis of symmetry. We know we can figure out the axis of symmetry from this formula, right? Because if we write the formula in terms of this standard form, then we'll have, and this is why it's tricky, we need to reorder it so that 3 is last and negative x squared is first, right? So if this is the formula, then what is the vertex? Well, we know that the x-coordinate of the vertex is equal to negative b over 2a. And b in this case is 4, right? Negative 4 over 2 times negative 1, because 1 is, or a is negative 1. So that's equal to 2. So x equal to 2 is the axis of symmetry. And then the y coordinate would be, you would put the 2 inside the x, and then that would give you that. Okay, the other way is, you already have the graph here. We already know how to find the vertex of any parabola given the graph inside the calculator, right? All we need to do is do second calc. In this case, it wouldn't be minimum, right? It would be maximum because it's pointing up. And so we're going to mark the left boundary, and then we go over to the right boundary. There we go. And then we do a guess. And so it says that the point is x equals 2, and it's 2.00008, but that's the same thing as 2, right? And y equals 7. So now we have that the y coordinate is 7 for B. So the coordinates of B would be 2, 7. And we could have gotten that 7 also by putting 2 into the formula. So we could have put like 2 squared plus 4 times 2 plus 3. And so that would be 4 plus 8 plus 3. Or there would be a negative in there somewhere, right? X squared. Yeah, because it's negative, it's negative x squared plus 4x plus 3, so it would be negative 2 squared. So it would be negative 4 plus 8 plus 3, so that would be 7, just like we got on the calculator. So either of those two methods is fine. Just going to erase this. Another point, C, which lies on the graph y equals f of x, has the same y coordinate as A. So I've already labeled that here. So we have a C point. We have a point called C, which is the reflection of A. So it says plot and label C on the graph above. We just did that. And then it says find the x-coordinate of C. So this, we're just going to use the fact that the parabola is a mirror image of itself. And so we know the coordinates, we know the x-coordinate of A. It's 0, right? Because it's on the origin. And so we use that fact to figure out what this point is. If this is 0 and the middle is 2, then what would be the exact reflection? Well, if this is 2, this is 2, so the exact reflection would be at 4. So the x-coordinate of this point C would be 4. Okay? And that's it for that one. I'll go ahead and do number 3 in the same video. So number 3, the graph of a quadratic function f of x intersects the horizontal axis at 1, 0 and the equation of axis symmetry is x equals -1. Write down the x-coordinate of the other point where the graph of y equals f of x intersects the horizontal axis. When they say it intersects the horizontal axis, that's the same thing as saying the x-intercept. And if they say that it crosses the horizontal axis at 1, 0, then one of the x-intercepts is 1, right? X-intercept 1. So we're just trying to figure out what the other x-intercept is. Again, we're going to use the fact that the parabola is a mirror image of itself to figure this out. So they said that the axis of symmetry is x equals -1, so that would be this line here. So we know that the parabola is centered here. And then they also told us that one of the x-intercepts is here at 1, 0. Then it says, where is the other one? Well, the mirror image of this point would just be over here, right? So that would be x equals -3. So the x-coordinate of the other point would just be -3, 0, and we just found that by reflecting this point over this one, right? There's 2 units here, we just reflected 2 units over here, and then we see it's there. Okay, y equals f of x reaches its maximum value at y equals 5. So that means along this line here, the y-coordinate of the vertex is going to be at y equals 5. So we're going to put that point here. So the parabola is going to basically look like this. Highest point here, vertex, and then it's got 2 x-intercepts at -3 and 1. Write down the value of f of -1. So when x equals -1, what does y equal? Well, it's equal, they just told us it was y equals 5. They just want to make sure that you understand this notation. Okay, find the range of the function y equals f of x. Okay. Now in this case, they never told us the domain, so the domain is going to be everything. So the range is going to be what does y vary in between for this whole parabola. And so we can see that it goes on forever in this direction. So it ranges from negative infinity to, and the highest value is y equals 5, right? So that would be like the 2 limits, and we could just simply write that by y is less than or equal to 5. If we say that, then it assumes that the bottom limit is negative infinity.